Okay, everybody, moving on. We talked about hydrates, and now we're into just a little bit of just a quick little lesson here on converting in between different values that equate to the mole. All right, again, we talked about the mole being a very, very useful thing in chemistry because the way that reactions take place and the way we look at formulas, we always look at the number of ions, the number of molecules, the number of particles, atoms, ions, being important to how things react and how things get together and form bonds. So it's an important thing to know that to how to go between the different values of the mole. So we talked about the mole in this case being, um, 1 mole being equal to the 6.02 times 10 to the 23rd particles thing, right? And then how do we do that? Well, we get that by weighing out the gram formula mass of something from the periodic table. And we can also equate that to 222.4 liters of any gas, right, at STP. All right. So I just put this up here just to kind of remind you quickly what the mole is, right? Well, what if we want to go in between these we want to convert in between them? Okay, so this is really your equality. 1 mole is equal to this. It's also equal to the GFM. It's also equal to the 22.4 liters. So how do you quickly convert between them? And some I like to use a visual for this, and sometimes we call this the mole map or the mole wheel, or even the mole triangle. Okay, and it really has the mole as our central spot, surrounded by spokes on this wheel of the other measurements. So we have liters up here in the left corner, grams over here. We have moles in the center, and the number of molecules here. Okay, so it's important to realize that looking at this mole map, and again, this is not the only way to do this, is to realize that you cannot go from any quantity to another quantity without going through the mole first. So, if you went to the mall, or you went to, if you had a GPS and you had to look at a map, you could think of this as being a map. Like, so you're traveling from the mole out to these other things, and you want to travel from the mole out to here or out to these other quantities, or you can go from the other quantities into the mole. Okay, so again, the mole is going to become an important part of this, and you can work in numbers of moles, but you can always go back out to the other things. All right, so there's really 3 ways to do this. I'm going to show you the 3 ways. Again, you can use one that's the most, more useful to you. But again, I think I know the best way to do this, and you got to be able to do this quickly too. Okay, so one thing you want to realize about this particular map on how to use this is one idea, and we're going to call that dividing in and multiplying out. So whenever you go into the mole from the outside, so if you're going from liters to moles or grams to moles or number of moles, so you're following these in arrows. Whenever you go into the mole, in, and in, you're going to divide into the mole, okay, by something, okay? And if you're going to multiply out, so if you're going out to the mole and out to the mole and out to the mole, from the mole out, you're going to multiply out. All right, so what we're going to do is, if you're doing this in liters, then you're going to divide and multiply out by 22.4. Again, 22.4 is 1 mole. So if you're going out of the mole, you'd multiply the moles by 22.4 to get liters. If you wanted if you wanted moles, you would take the number of liters and divide by 22.4. Now, when you're doing mass, your link is going to be the GFM. So you multiply by the GFM going out, divide by the GFM going in. Okay, and if you wanted number of particles, you would multiply out by 6.02 times 10 to the 23rd, or you would divide in by 6.02 times 10 to the 23rd. All right, so putting these little values on here really does help. Okay, and you can use the little phrase DEMO, divide in and multiply out. Okay, so it really gives you a good visual on how you can easily convert one thing to another based on what the problem asks you to do. Now, again, you don't have to do this. You could simply use the second way you could do this, besides the map, is using the reference table. And the reference table is a simple little equation that says the number of moles is equal to the mass in grams that you're given divided by the GFM, which is really the same thing as using this spoke on the wheel, right? If you have your mass in grams, you would divide in to the mole in this direction. You would divide in by the GFM, which is exactly what you're doing here. Or the third way is using dimensional analysis. So again, you could choose which one you want to use. So there's three ways. You can use the mole map to convert. You can use the reference table to convert, right? Or you can use dimensional analysis to convert. Okay. Me personally, I like the mole map. So I'm going to show you how to use the mole map first with this problem, and then you can do it. Again, this is also easy to kind of memorize. Okay. So let's just say we had a problem where we're going to convert. Let's just say I want to know how many liters. Okay. So I'm looking for how many liters does 56 grams of N2 take up at STP. All right. So we're assuming STP. So I'm given 56 grams. So I'm going to start with 56 grams of N2, and I want to find my liters. Okay, so if I go up to my mole map, where really am I on my map? Well, if you remember the "You Are Here" button, okay, on any map you go to, they usually say "You Are Here." If I go up to, I'm giving my mass. So my mass, I'm actually here, right? I'm up here in my mass. And it's asking me for liters, which is all the way over here in liters. Now, there's no direct way to go all the way to liters. We're going to have to go into the mole first and then calculate and then just go out of the mole. So we want to go into the mole and then out of the mole. So how do you want to go into the mole? Well, we got to go into the mole by dividing in by the GFM. So on the other side, we're going to say, okay, what's the GFM of N2? That's really going to be 2 times 14, which is 28 grams per mole. So now I have the GFM. So as long as I have the GFM, I'm going to go and divide into the mole by the GFM, which means I'm going to take 56. I'm going to divide that by 28 grams per mole. Okay. And again, if I want to calculate that out, I can, but I really don't have to. I simply can say, okay, now I'm in the mole. I'm looking for number of liters. How do I get to liters? Well, now that I'm in the mole, I simply are going to multiply out. So let's just multiply this out just for the heck of it. I'm going to say 56 divided by 28 is exactly 2 moles, right? So think of this as my first step, all right? And now that I'm in 2 moles of N2, now that I'm in the mole, I want to multiply out to get to liters. Well, what do I multiply by? 22.4. So I can multiply by 22.4 liters. And I get 44.8 liters of N2. So very simple, right? Now, another way I could do this, I could simply use dimensional analysis. Okay, so another way you can do this. So this would be it. And again, you use the mole map. That's great. So now we found our answer. Another way to do this is using dimensional analysis. We could say 56 grams of N2. Okay, and then we can divide by the GFM. That's what we're going to do here. But we can phrase it differently. We can say there's 28 grams in 1 mole, right? So I'm using that as my factor. Remember, the gram formula mass is a conversion factor. Remember, it's 28 grams. What does that really mean? Equals 1 mole, right? So that would cause me to cross out my grams, all right? And now that I'm in the mole, I want to convert that to liters. So I just position my conversion factor. I know that 1 mole would have to be on the bottom to cross out diagonally. Of course, that's what dimensional analysis is, right? And then you're going to go 22.4 liters. And guess what you get? 56 divided by 28 times your 22.4. And guess what you get? 44.8 liters of N2. So either way you want to use it is fine. I tend to like the mole map better because you can it's dividing and multiplying out. It's your demo. So as long as you know what this is and you know this part of it, and again, you can use that for number of particles as well. Okay, just remember with, I'll just put that here for the heck of it, 6.023. Remember, you can use, this can be the EE button in your calculator. Like, so if you have a scientific calculator, that's your EE button. So if you type this into your calculator, it would be 6.02. You would hit the second function EE, which would give you the small little e here, right? And then you would say 23. And that would be your 6.02 times 10 to the 23rd. So make your life easier that way. All right, so that's really how you use the mole map. We'll do a couple examples on the other page to fill out the chart, okay, and then the rest will be up to you. So if we go to the next page, we'll see, if you want to think about the mole being your way and think about this, the way to do it, you can even think about this and get these kind of easy. If I had 1 mole of iron, okay, that really is 56 grams, which is the GFM, right? It is the GFM. Okay, we wouldn't really worry about liters because iron is a solid in this case, and that because it's 1 mole, that's always 6.02 times 10 to the 23rd. If I had 2 moles, okay, of this, again, how do I find the number of grams? I would have to multiply out by the GFM. So let's just find them, again, using the mole map. If I have moles and I want to find grams, I'm going to multiply out, but I need the GFM. So the GFM of this is nitrogen would be 14. Okay, 3 times 1 is 3. So 17 grams per mole would be my this. I would say 17 times this, right? Because I'm multiplying out by the mole. Okay, and I would get 34 grams. Okay, and again, if I want liters of that, I would take 2 times, I would multiply by the mole, right? So this is really 2 times 17. This would be 2 times 22.4 liters because I'm multiplying out from the mole. I would get 44.8 liters. I also would take 2 times 6.02 times 10 to the 23rd, and I would end up with 12.04 times 10 to the 23rd, right? Same thing here with CO2. If I have half a mole CO2 and I want to find the grams, I'm going to multiply out by the GFM. What's the GFM of carbon dioxide? I'm going to say 12. This is 2 times 16, which is 32, for a total of 44 grams per mole. Okay, so I would take a half, multiplying out by the GFM. 40 times 44 would be 22 grams. Okay, and I would multiply a half times 22.4 liters. Okay, and that would give me 11.2 liters of CO2. Okay, 11.2, that should say. 11.2, and of course I would take 0.5 times 6.02 times 10 to the 23rd, and I would get 3.01 times 10 to the 23rd. Okay, and what you can do is I'll let you finish these here, okay, and check that out. And again, all we're doing here, guys, is, and girls, are converting factors in the mole. Okay, and again, this is crucial. You have to be able to do this quickly, and you have to be able to think about it quickly too in order to do the next thing. Okay, so use your mole map, use the dimensional analysis. I don't recommend using the reference table for that other one, but I mean, if that's something you want to use, you can. But I think either one, if you adopt either one, I think you'll be successful. All right, have a great day. Talk to you soon.